Gautier was launched in March 2009 and was positioned in a very low orbit only 250 kilometers above the Earth's surface. From that orbit, Gautier measures our planet's gravity field with a precision never obtained before. At school, we learned that the Earth's gravity is 9.8 meters per square second. But in reality, this is not entirely true. The gravity field does show differences. Gautier feels these small differences in two ways. In the first place, the satellite is tracked by GPS satellites, and every small change in its orbit caused by gravity is recorded. Secondly, Gautier has unique specialized equipment on board, its centerpiece being a so-called gradiometer. It measures minute changes in the gravity field, down to only 1 part per million of G. The amount of data that Gautier has already sent to Earth is impressive.
Here we get in the order of 6 to 8 measurements per second, which means that we have several hundred millions of observations which have to be then processed to get finally a model of the global gravity field and many derived products.
The result of Gautier's work is the most detailed map ever of the gravity field. In the Antarctic, for example, the red zones show that Earth's gravity is stronger than in the blue zones, and that reveals a lot about what's underneath the icy surface. Interpretation of Gautier data will also help scientists to better understand the global ocean circulation system, and that will be an important step to get better insight into climate change.
It will be possible, using Gautier data in combination with other satellite data, to determine from space global ocean circulation. We know that the oceans is nothing but a huge heat engine determining to a large part, apart from the atmosphere, our climate. So it is very important to understand how this engine really works, and I think in this respect we will make a major step forward.
The data collected by Gautier also teaches us a lot about what's actually inside the Earth. So we'll get a clearer view of how the surface plates behave, for example, in earthquake zones.
We will gain a rather detailed knowledge of the Earth's gravity field, so to say, a look into the Earth's interior, which will help us to better understand tectonics, how plates behave, how they bend, what anomalies there are on continents and in the oceans.
Another result of Gautier's work will be useful for engineers worldwide. This is the new refined model of the so-called geoid. To understand this geoid, we need a bit of imagination.
If the planet would be covered completely by water, the gravity field inside, or the gravity field of Earth, would shape the sea surface like that. If we had no land masses, nothing, the sea surface would look like the geoid.
This model is widely used by all kinds of scientists. It's been calculated previously, but never with the precision that we can see now. This global sea level reference will be used worldwide as the zero level of heights. This is very important for GPS navigation and major engineering projects. So the scientific world has been really thrilled by Gautier's work, and the great news is that there is even more to come.
We have fulfilled the specified mission, but of course the scientists are very hungry to receive even more data, because the geoid becomes also better and better the longer we measure. So we have fuel for maybe another 2 years. We plan to use all fuel as long as the satellite is healthy, but we are now glad that we have fulfilled the mission we have planned originally.